Okay, so in Foundations of Math 10, in 3.8, we see that we are factoring some special polynomials. One of the special polynomials that we're going to run into is called a perfect square trinomial. So in order to show you what a perfect square trinomial looks like, what we're going to do is we're going to evaluate or simplify some of these, expand these out. So let's do this together. X plus 1 squared, this first one right here. Do you know what this squared means? It means that we're multiplying whatever this squared is attached to, that's this binomial, we're multiplying it by itself 2 times. So it looks like this. X plus 1 squared is the same as x plus 1 times x plus 1. And that's actually pretty easy for us to do because we know how to distribute. So that's x squared plus x plus 1. That simplifies to x squared plus 2x plus 1. All right, let's pick another one. I'm gonna skip around a little bit. So let's do this one right here. So 2x plus 1 squared, of course, means 2x plus 1 times 2x plus 1. We're going to see that. And when we do our FOIL here, we get 4x squared plus 2x plus 2x plus 1. So that comes out to 4x squared plus 4x plus 1. All right, let's do another one here. Let's do this one right here. Okay, so in blue we have 3x minus 1 times 3x minus 1. Do our FOIL method again, or distribution, we get 9x squared minus 3x plus 1, which simplifies to this. Okay, so obviously we could do more of these, but I'm going to take just a look at these 3, and I'm going to try and help you sort out here some patterns, right? There are some patterns when we multiply a binomial times itself. There are some definite patterns that emerge when we do that. And so if you look here at the second step, okay, what do you notice about the second step in all 3 of these cases? Is there anything that jumps out at you? Anything that's similar? Is there a pattern at all? Anybody? There would be a number of things actually that you could notice. The first thing that I noticed that jumps out at me is this part right here in the middle. That we are actually adding the same term here, right? We're combining the exact same term in all 3. And that is a characteristic of perfect square trinomials, that this is part of the process of finding them. Now, when we multiply something by itself, okay, one of the other things that you could notice, or that you might have noticed, is that this first term is always the first term times itself. This is always the first term times itself, because that's the first step. The first term times itself. And another thing you might have noticed is that the last term, so if we skip down here, the last term is always the last term times itself. See? The last term in the binomial times itself. The last term times itself. So there are some patterns there. And I guess this whole section is asking you to take a look at what these trinomials look like right here. Take a look at these trinomials and recognize that they actually come from a binomial times itself. And that's what a perfect square trinomial is. It's a trinomial where the factors are identical. The binomial factors are identical. Okay, so let's just jot that down maybe. Okay. Whoa. Perfect square trinomials have binomial factors that are identical. Okay, so let's just summarize what we see here in these examples. So let me just show you this. if you just take any a and any b term and you multiply that binomial by itself, the FOIL method says that we are going to get a squared plus 2ab plus b squared. That's what we get when we multiply out. Now I want you to look at the pattern here. Okay. For example, and I'm going to just change this up a bit again. This was, you don't have to rewrite this actually, you just watch. But this was x plus 1 squared. This was 2x plus 1 squared. 3x minus 1 squared. So if we take a look at this pattern for perfect square trinomials, if I take a look at x and I square x, I get this term. If I take a look at plus 1 as being the second term and I square that, I get plus 1. See, that's a, the first term, squared, and b, the last term, squared. The middle term, okay, interestingly enough, is x times 1 times 2. See? A times b times 2. So whatever the product of those two terms is, multiply it by 2. That is your middle term. And that's the pattern throughout. So 2x times 1 is 2x, times 2 is, look at that, 4x. 3x times negative 1 is negative 3x, times 2 is negative 6x. So what I want you to see is that there's a pattern in multiplying a binomial times itself. There's also going to be a pattern when you look at the trinomial, like this, and you're trying to go back to the binomial. So let's just say, for instance, I give you this trinomial right here. Okay, this one right here. And I tell you that it's a perfect square trinomial. So you automatically know that it has two identical factors. What you're going to do to find those identical factors is take the square root of the first term and put it right there. You're going to take the square root of the second term and put it right here. Now, you don't know really whether it's a plus or a minus in this case. That's when you look at the middle term and say, this is a plus 2, so I'm going to go, this is going to have to be a plus 1x and a plus 1x there. So it's pretty straightforward. Again, same thing over here. If I just gave you this as a perfect square trinomial, and I told you that, then you'd say, okay, so the factors are going to be like this. The square root here is 2x. The square root over here is 1. This is a plus 4x, so does this have to be a plus or a minus? It's going to be a plus. And the same thing over here with this one here is we're going to have a binomial that's squared. So what's the square root of 9x squared? It's 3x. What's the square root of 1? Is 1. This is a negative 6. So in order to combine, so 2ab, this would have to be a negative. And that's how you do that. That's a perfect square trinomial. So let's take a look at a couple perfect square trinomials and see if you can do it. Are you ready? So let's say we have something like this. X squared plus 6x plus 9. So if you factor this, you know how to factor this. This is pretty easy. You find two numbers that multiply to 9 and add to 6. Right? And so if we know that 3 and 3 are the numbers, guess what? This is a perfect square trinomial because the factors are going to be x plus 3 plus 3. That's x plus 3 all squared. So that's a perfect square trinomial because the binomial, the factors are identical. One more, let's do another one that's a little tougher. So let's do this one. 4k squared plus 12k plus 9. Okay, so this one here, if we factor this, Notice this. Notice this. This is a perfect square number. This is a perfect square number. As soon as you see that, you're saying to yourself, this could be a perfect square trinomial. It could be. It doesn't have to be. But as soon as you see that this is a perfect square and that's a perfect square, that's your hint. Okay? So let's see if it works. What's the square root of 4k squared? That's 2k. What's the square root of 9? 3. This is a plus, so let's try this. This is a plus. Now, is that the factored form? Is that the factored version here? Well, if you do a quick FOIL in your head, that's 2k squared. This is 6k plus 6k. That's 12k. Plus 9. There we go. That's it. So a perfect square trinomial has some special characteristics. And again, what you want to look at is, hey, are the first and last terms perfect squares? That's really important. So let's write that note down. A perfect square trinomial has the first and third terms as perfect squares, or they are perfect squares. And those are the ones we've highlighted there. Okay, any questions about perfect square trinomials?